Hi, Alex. Thank you so much for agreeing to meet with me today on this beautiful sunny day in Monaco. We are here to talk sustainability. Data centers have this rep for being this necessary evil in the world. So what can data centers do to implement a sustainability strategy?
It's interesting for you to introduce data centers as perceived for the general public as a necessary evil. I do think that there is a general perception that data centers are just these power-hungry, water-hungry facilities, and not a clear understanding of the role that data centers play in our society outside of feeding us Netflix, which is of course important in its own right. But I think it's important for us to remember that data centers are an essential part of every important climate solution. So if we think about everything from EV charging to renewable orchestration to every aspect of the smart grid, every important climate solution is a digital solution and requires a data center in order to be successful. And there are several aspects in terms of what a data center operator can do. Certainly, starting with renewable energy procurement, we have hyperscale data center operators who have led the way not just for the data center industry, but for the entire private sector in terms of their aggressiveness and ambition in renewable procurement, and has therefore been able to change the entire renewables industry. Other aspects that data center operators are looking now are in scope 3. So they're looking at their supply chains and what is the embodied carbon of the equipment that is going into building the data center, both the materials, the equipment, every piece of physical infrastructure that goes into building the data center has embodied carbon from resource extraction, manufacturing, delivery. And so we're working now in Schneider to make sure that we're leading the way in terms of measuring and reporting on that information so that data centers can act on it.
Can you go into a little bit more detail about sourcing?
Sourcing procurement has 3 different pillars. The first is power. What kind of power are you purchasing from the utility or from a separate contract, like a power purchase agreement, specifically with a renewables project, like a solar or wind project? Pillar number 2 would be those materials that go into the core and shell of the data center. And here we think a lot about steel and concrete, things that are high in embodied carbon, the carbon that went into creating those materials. And there's exciting things happening to decarbonize those sectors. Hydrogen and steel is an interesting one right now. And then the third is manufactured equipment, is separate from materials. And so that equipment's for the power distribution system inside the data center, the cooling system, everything that supports the IT inside the data center, and then IT itself. So there we're looking again at materials. So what materials are going into that equipment? And since they all have microchips inside them, there are a lot of rare earth materials there, more scarce materials. And so we're looking at, again, everything from resource extraction at the mine all the way through delivery of the item to the data center. And then, of course, efficiency in operation is part of the embodied carbon, the life cycle carbon of a piece of equipment. And it's something that's very important to us at Schneider. So we're looking all the way from that mine to end of life for the piece of equipment. Can it be recycled? Can it be refurbished to extend end of life? Those circularity aspects. But efficiency in operation should not be overlooked.
Technologies like, for example, UPS have the ability to give back to the grid. Do you think this is also part of the whole sustainability angle? Is this something that should be explored more by data center operators or vendors like yourself?
Without a doubt, grid interaction presents all kinds of unique capabilities that can improve the business case for on-site distributed energy resources. Right now, when you look at what energy resources data centers have on site, they have diesel generators typically, capable of meeting the entire load of the data center in most cases. And then, as you said, UPS, so battery storage that carries that quick ramp when we lose power and gives time to go to the diesel generators. So the UPS itself can be made to be grid interactive. And that's something that Schneider is also working on and delivering to data centers right now. And we need to look at that grid interactive capability when we assess what is the successor technology going to be to diesel generators. So Microsoft has announced that they will retire or eliminate diesel fuel from their data centers by 2030. And that's sort of lit a spark for the entire industry as data center operators consider what's going to be next after diesel generators. So UPS can be one conduit for that grid interaction, but it's good to think about how can we use on-site energy generation, not just for backup like we do for UPS, but as prime power. So if you have natural gas turbine or engine, if you have fuel cell that's large enough to meet the load of the data center, well, that can be used for prime power. And then you can have a control system that says, I'm going to select the least carbon source of energy at any given time through that grid interaction. I'm going to select the least cost source of energy at any given time to automate participation in demand response, take advantage of time of use rates and things like that to optimize on cost. And then make sure that you have all the controls and telemetry necessary to understand what is the carbon impact of the utility power, that's the carbon impact of the power we're generating on site, and any other kind of offsite PPAs. So that all can be orchestrated automatically and optimized on carbon on an hour-to-hour basis. So there's a lot of potential there, and it's a very exciting territory for the data center industry at the moment.
You mentioned 2030, but that's quite far away. Do you think there's something that maybe organizations could be doing to encourage sustainability? Maybe governments should be a bit more stricter, or there should be more enforcement on these kind of rules?
There's a lot of different policy actions that can support this transition to sustainability. And one is what you're referencing. Governments can be more demanding in terms of emissions regulations. And we're certainly seeing that drive the transition away from diesel generators. So we see where there are local emission regulations, it's difficult to get a permit for a diesel generator. It can slow down an entire data center project. And as we know in the industry, any delay at all can be astronomically expensive in terms of date to market. So that's also driving interest in the data center industry in retiring those diesel generators and finding the next technology to take over. Governments can also help through public investment. We're seeing this both in the United States and in Europe right now, support for technologies like behind-the-fence data center microgrids, renewables, battery energy storage, and not just for adopting these technologies, but for all of the supply chain that will go into making them available and less cost. And we saw that work with the solar industry. So we had a massive public investment in photovoltaics. The United States at first, but then really more Japan, Germany, and eventually China. And those investments conspired to bring down the cost of voltaics exponentially. They're at something like 5% of what they were only 20 years ago.
In terms of challenges that you think colo offers, what do you think is the predominant challenge that is faced?
I think some of the challenges are organizational. So we spoke earlier about scope 3 emissions and the need to report an embodied carbon. That's not done in a consistent and standardized way at the moment. And so it's difficult for data center operators to compare one piece of equipment to another based on embodied carbon. It's really important that we get to that place so the procurement decisions can be driven not just by costs and delivery, but by carbon as well. We've heard firsthand from the data center operators that we work with that they want to make carbon part of the RFP process. It's difficult to do so because of that lack of comparability. We at Schneider are working with industry organizations like the Open Compute Project and iMasons on different aspects of that standardization. The OCP project is a little bit more focused on IT and carbon modeling. iMasons through the Climate Accord is working on guidance for all of the signatories to the Climate Accord, which includes just about every data center operator and vendor to the data center industry you can think of. Say, what can we issue in terms of guidance that will lead to the transparency we need to understand carbon declarations from one company versus another? Maybe be able to standardize those so that we can drive procurement decisions based on carbon.
Do you have a timeline of when these kind of guidelines will be?
We're hard at work at Masons right now and at OCP. I think that in 1 year time, we shall have a lot more to say on the topic.
Finally, there are a lot of geopolitical tensions that are going on in the world right now, supply chain issue, delaying projects. How much do you think that's impacting sustainability progress in our industry?
In many ways. Some are constraints and some is actually opportunity. What we're seeing right now is volatility in energy cost, and that's absolutely driven by geopolitical events. We see impacts to the energy system directly from climate change in the form of severe weather, drought, wildfire. And so what that presents is an opportunity for the data center industry to think about sustainability in the frame of resilience. And it happens that a lot of sustainability solutions are also terrific solutions for advancing resilience in the data center industry. I'm thinking about a diverse energy procurement portfolio that includes renewables, which are immune from fuel cost fluctuations if they don't use fuel, as in the case of photovoltaics and wind. Also, energy efficiency. We have realized terrific gains in the data center industry in efficiency, driven by the power use effectiveness, PUE metric, but we still have a lot of ground we can cover, and the more efficient a data center becomes, the more resilient it is to power supply constraints, to energy cost fluctuations, and outages from the utility. And then finally, all of the solutions that we discussed around data center microgrid and what the successor will be to diesel generators, we can start to think about what kinds of on-site energy solutions would allow a data center to remain powered over a 2-week outage rather than just several hours? And how can that help a data center not only be more sustainable, if it's a clean on-site energy or a cleaner on-site energy system, but more resilient again to all those outside forces?
Well, Alexander, thank you so much for your time today, talking to us about sustainability in data centers and so much more. I really appreciate your thoughts.
My pleasure. Thanks for the conversation.